Hey kiddos, today we are going to be doing Unit 3, Lesson 6, which is the same triangle congruencies that we've been doing. Side, 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 angle, side, angle, side, angle, 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 side, and a hypotenuse leg. But today we're going to deal with overlapping triangle congruencies, okay? So let's talk about how we deal with overlapping triangle congruencies. The first thing that I would say to do is to separate the overlapping triangles. So let's look at example 1. I have triangle ABC. So here's ABC. And then I also have triangle DCB, which is this one right here. So what I'm going to do is I'm going to separate these, okay? I'm going to separate them like this. So you can see I have ABC still down here, and I have DCB right here. And I did my best to make them look the same as the original, okay? And then notice that I went ahead and I labeled them as well. A is on the bottom, B is in the middle, C is on the top. And then I did the same thing with the pink triangle. From left to right, from top to bottom, B, C, D, B, C, D. Now what I want to do, so I've done separating, I've done labeling. Now let's mark all the congruent sides or angles. So BC is the same as CB. These are congruent because that would be the reflexive property. They're the same side, okay? So BC is going to be congruent to BC. All right, and that's it. And then hopefully later we'll be able to determine, are the triangles congruent? We don't have enough information in this particular problem to be able to determine that, okay? So for the first 3 examples, all I really want us doing is practicing steps 1 through 3. Separate them, label the sides or the angles, and then mark all of the congruent sides or angles. So let's do number 2 together. I have triangle BYA, and then go ahead and continue it around. So here's what this would look like if I did that on my own. I tried to make even the way that the triangle was slanted be the same. So this would be B, this would be A, and this would be Y. And then I went ahead and I marked the right triangle or the right angle at Y and the line at AY. Okay. Now let's do the other one. CXA. CXA. And I went ahead and I drew that out. I tried to make it match how it looked. Okay. I already drew on there the right angle and then the dash. So CXA is right there. So what can I say about these 2 triangles? Well, I can say that AY is congruent to AX because that was labeled for me. And I can also say that angle AXC or AYB, let's start there. Angle AYB is congruent to angle CXA. Or I'm sorry, AY, so AXC. AXC, and that's an angle. Okay, so I've marked all the congruencies. In order to prove them absolutely congruent, I would need some more information. Okay, let's do example 3 together. Example number 3. MPN. So let's look at that. MPN goes this way and then continue it. So here is MPN. And I already labeled the letters, okay? Now let's look at our second one, MOQ. And so there, I went ahead and drew that out, okay? MOQ. And so that is my second triangle. So what kind of congruency statement can I say about this triangle? Well, right in here, O to P overlap. So I can say OP is congruent to OP. And that's it. That's all that I know for sure that I can actually say. Okay, awesome. So we've practiced separating triangles. Let's go ahead and look at a proof of one from start to finish, okay? So our job is to prove, okay, given angle M, the measure of angle FEH. So FEH is 90 degrees. So FEH, and let's go ahead and create this triangle, okay, is that angle measure is going to be congruent to GFE. So GFE right here. And both of those are equal to 90 degrees. So the first thing that I'm going to do is separate these two triangles, okay? So mine might not be perfect, but I'm going to try. So there's E, there's F, there's H. They said that that was a right angle and that I'm about to get to that, but EH is going to be congruent to FG, okay? So let's try to draw the other triangle. So this is F, this is E, and this is G. So if you wanted to see those true triangles separated, this is what they look like. All right, and then don't forget my blue one. And I've taken all the given information and I've marked it. So EH is congruent to FG, EH is congruent to FG, okay? Okay, so I was given that these sides are equal to 90 degrees, and I was given that EH is congruent to GF. Now let's take a look at this. FEH is congruent to EFG. Well, that's true. How do I know that? Well, I know that all right angles are congruent. They all equal 90 degrees. Okay, let's take a look at another one. The next step says EF is congruent to FE on the other triangle, FE. And here's where they would look. Let me do two tallies because it's the second congruency. That's where it would match up if on the overlapping. So how do I know that these two are congruent? Well, that would be the reflexive property because it's the same side of the figure. So that's the reflexive property. Okay. Now they want to know, what is it that we know? And they already told me the reason is side angle side. Okay. So we can say that triangle HEF, triangle HEF, I'm going from side 1 congruency to side 2, okay? It's going to be congruent to the side 1 congruency from GFE. GFE. Oh, and that's a triangle. So I know that these two triangles are congruent by side angle side, okay? So this is something new that we haven't actually seen before. They want us now to determine that HF right here is congruent to GE right here. And how do we determine that? Based on a side angle side. So we learned that corresponding parts of congruent triangles are congruent. Well, we just proved that these are congruent by side angle side. So that means all the other parts are congruent as well by the corresponding parts, okay? So corresponding parts of congruent triangles are congruent. That would be the reason that I could say angle H is congruent to angle G, angle E here, FEG is congruent to EFH. I could say any of those other things are congruent to each other based on corresponding parts, okay? So that's also a good example of how we use corresponding parts of congruent triangles are congruent, okay? But we had to separate them in this case. Fantastic. You might need to pause this if you missed anything. I'm going to go ahead and move on to the back side of our paper. Okay, so let's deal with some EOC style questions. What is the common angle of PQT and RSQ? So let me move my video a little bit. Okay, so let's first just draw out what these are. PQT, that's that triangle right there. And I made it pink. Okay. And then the other triangle is RSQ. RSQ. What was the one and only one angle that they had in common? And it was right here. Okay. They shared angle Q. Well, what is another way to say angle Q? Okay. Remember, the two ways that I could say angle Q, and there's actually a lot here, I could say PQT, I could say PQR, I could say SQT, and I could say SQR. But what do all of these have in common? Okay, so if I want to talk about just angle Q, the Q, however you label it, has to be in the middle. So we want to pick the answer choice that has the Q in the middle. And that's this one right here. Okay, option A has the Q in the middle. So that's just sort of a reminder of both how do we look at overlapping triangles, but even when they're overlapping, how do we name a shared angle in them, okay? See, so angle Q could be written all these different ways depending on which particular triangle that you were talking about, okay? Okay, let's take a look at a proof And we're going to go through all these different parts. I'm going to zoom in a little bit more. So this figure is going to help me with the rest of the notes for today. So given that ZWX, so ZWX, okay, so I'm going to recreate that triangle. And that is going to be congruent to YXW. So let's draw YXW. All right, so I have YXW. Okay. So sometimes it's helpful to come to a final conclusion looking at them independently, and then we can work a few things out by looking at them overlapping, okay? So which corresponding parts statement is needed to prove that ZWR is congruent to YRX? So these two little inside triangles. Okay. What do we need to know about that? So this is question 1. So let's take a look at through here, okay? So let's start with, I guess, WX is congruent to WX. Does that help me at all inside these little triangles? And no, it does not help, okay? What about ZW? ZW equals YX. Will that help me? Will that help me with corresponding parts? I'm not sure, but let's save it, okay? Let's look at G. Angle Z. Angle Z is congruent to angle R. Well, angle Z is on the inside. Angle R is on the outside. So that's not really going to help me either. And then let's see. ZWR is congruent to YXR. Would it help me to know that? Okay. So I've got two different things here, and I need to determine which one is going to help me with corresponding parts. Okay. So I know that these are parallel as it is. Let me make that a little bit bigger. ZW and YX. Okay. What's going to be most helpful here in which corresponding part statement is needed to prove these triangles is going to be ZW. ZW is congruent to YX. Okay. Why is that the most helpful? Well, because I know that the pink triangle is congruent to the blue triangle. And so that's the information that I can gather from here. Okay. Now I know that those two sides are congruent. So this is H. ZWR, that isn't anything I can gather from the original triangles. So that's why that's not going to help me, even though it is on the inside here. It doesn't include the original pink or blue triangles. Okay. Okay. Next, a classmate writes a statement that ZRW, so ZRW is congruent to YRX to help prove the congruence of the triangles. So let me mark that. they say that these two sides are congruent. How can we say that those two angles are congruent? Are they angles cut by a bisector? Are they base angles of an isosceles triangle? Are they vertical angles? I skipped right over A because that information was not given to me at all. I forgot to highlight this up here. That information was not given to me. So I know that that couldn't be it, okay? And if you remember our theorems, these are vertical angles. These are vertical angles. So vertical angles are congruent, okay? After using the congruent statements from exercise 2 and 3, which statement can be used to prove that these are congruent? So let's check. Angle Z is congruent to angle Y. Angle Z is congruent to angle Y. So Z and Y. Would that help me prove that the yellow angles are congruent? I would have angle, angle, side, angle, angle, side. That is a possibility. So I'm just going to put a check there. Let's check our other options. ZWR is congruent to RYX. No, because those are on opposite angles. Okay. Okay. What about WX and XW? Yes, those are congruent. However, that's not going to help me either. Okay. That's not going to help me either because it has nothing to do with those yellow triangles. What about WR and RX? Would that help me? Well, that would give me angle, side, side, which is not. This would give me angle, side, side, which is not a theorem, okay? Angle, side, side is not a theorem. But if they want us to prove specifically the two triangles that they're giving us, which is ZWR and YRX, then this R here, these need to be congruent to each other. They need to go in a pattern. ZWR, YRX, okay? And so I can prove that. So it can't be G. And what angle am I using? Or I'm sorry, what theorem am I using? Well, I am using angle, angle, side. Angle, angle, side. Okay. All right, guys. So that is our lesson for today. I zoomed out a little bit so that you can see all of this. We do have a practice assignment for tonight. It is posted to Canvas. This is going to be a little bit more tricky than some of our other proofs because we do need to separate some things, okay? So this is the last lesson of this unit. And so from here on out, we're just going to practice and get ready for our test. Until next time.